Good morning, everyone. Hope you're feeling bright and excited and ready to learn. So my name is Mike. I'm based in Berlin. I make interactive art and experimental games that use non-traditional interfaces to connect people to the world around them. Do I have a working clicker? Almost. Nope, maybe not. Maybe. All right, we're going to improvise. Great. Oh. Interesting. There we go. Great. Auspicious start. So this is a piece called Computational Flaneur that came out of my research at the MIT Media Lab. This is a site-specific generative poetry walk. So you go to this park in San Francisco, you download an app on your phone, and then as you walk around, a robot makes up and reads you poems based on where you walk. So you walk by the cannons, you hear poems about war. You walk by the waterfront, you hear poems of the sea, that sort of thing. I think it's really cool. We'll talk a little bit about it later. But I mention it because I had a very specific problem when building it. Or rather, I had a lack of a problem. If you've ever built anything using GPS before, or even used it on your phone, as I'm sure all of you have, accuracy can vary. Like on paper, GPS gets you 15 to 20 meters of accuracy. If you're in the middle of a city, that can often go as high as 100. There's this really bad problem called urban canyons. They're the bane of anyone trying to build out location services in urban spaces. And we'll talk about how that works in a little bit. But what's more curious is that wasn't happening at all here. With this piece in this park in San Francisco, I was getting 2 or 3 meters of accuracy, which is unheard of. I didn't have to worry at all about accuracy. I could just build out exactly what I wanted. And that sent me down this deep rabbit hole of, OK, I don't know why this is working so well. How does your phone actually know where you are? And it turns out that's the wrong question to ask. The question, how do computers know where we are, isn't even the right question to ask. The question is, how have computers known or how have people known where we are throughout the course of human history, and how does that translate to how we get to where we are today? This talk is really going to be 2 different parts. We're going to start in broad strokes talking about what is the history of humans locating themselves in the world? What is this basic math that makes GPS tick at a fundamental level? With the idea being that this understanding might help you do your day-to-day jobs dealing with location services as designers or developers. And then we're going to get a little more conceptual and talk about, all right, well, why are we using location services? Why are this interesting? What are the sorts of things we should be building? And how can we use sort of design practices, and how do we build up systems to design interesting location-based apps? But first, let's go back in time. This is not the beginning of humans finding ourselves in the world, obviously, but it's a convenient place to start. It's the age of exploration. It's the 18th century. You're probably a mediocre Western European white dude trying to conquer the world. And you need to know where you are at sea so you don't get lost. Figuring out how far north or south you are is really easy. You can look up at the sky. You can see when it's noon because the sun's going to be its highest. If you measure that angle, you can consult a lookup table or do some basic math and know how far north or south you are. East or west is way harder. Figuring out latitude, or longitude rather, has been a solved problem on land for a long time, thousands of years, but for various uninteresting reasons, none of those techniques really worked at sea. So this period of time, like early 18th century, the best we had was dead reckoning, which is still a technique that people use today, especially if you're doing, like if you deal with like motion controls, you might have dealt with something like this. The idea is really simple. If you know, say, you're leaving London and you're going in this direction at this angle for this amount of time for the speed, you can sort of chart on your map and draw a line and say, I should be here. That's not great. It's not that accurate. It is so inaccurate that during the War for Spanish Succession in 1707, there was a single event where the British Navy lost about 2,000 soldiers over 4 ships in one night. And to be clear, this was not a battle. This was 4 different ships, each of which had a navigator that was independently doing calculations, and they were talking to each other, and they all independently said, I've crunched the numbers, we are definitely not about to crash into some rocks. And then all 4 ships crashed into rocks. So dead reckoning is not great. This is so bad that every major Western European nation had major cash prizes for whoever could solve this longitude problem. Spoiler alert, the answer is this thing called the marine chronometer. It's literally just a clock that works at sea. Why this was so hard to build is its own interesting topic that we're not going to get into. We're also not going to get into the amazing story of the British guy who spent 60 years fighting the British government to get his money. But what's more interesting is why this is actually useful, like it's a clock. So if you know where you are in the world, that's super easy. If you know your precise distance from a known location, that's super easy to figure out where you are. But if you don't know either of those things, what do you do? So you know how to figure out what time it is where you are. Again, it's really easy to look up and see, oh, it's noon. Also, if you think about time zones for a second, not necessarily human time zones, which are messy and complicated with things like daylight savings time and half time zones, and it's a giant mess. But at a basic scientific level, the Earth rotates 360 degrees every 24 hours, so you roughly change 1 hour every 15 degrees. So if you know what time it is where you are, and you know what time it is in a known location like Greenwich, England, you can take that time difference and know that for every hour of difference, you're about 15 degrees east or west of that location. So if you have a clock that works on your ship that is set to Greenwich time, you can know how far east or west you are of Greenwich. And again, it's really hard to get there for weird arcane reasons, like clock technology at the time didn't work at sea, but this basic idea was not new. People have been doing this on land for thousands of years. It goes back to Herodotus. But that turns out to be super useful and super important, this idea that time can be a proxy for distance. So if you fast forward to the 20th century, Sputnik has just gone up. It's the mid-50s. There are a bunch of scientists at MIT that noticed something really interesting, which is the closer Sputnik was to them, the more signals they got from Sputnik. There was sort of a Doppler effect thing going on. And that's not directly how GPS works, although that does play a little bit into GPS. But that set the stage for 10 years later when people were sitting down and saying, we have all these newfangled computers, how can we use them to improve location to help the Cold War effort and all these other things? So it was continuing this idea that if you have location, that's great. If you have distance from a location, that's great. We can use time as a proxy for distance if you don't know that. But this was the insight that we can actually use satellite signals as a way to get that time if we don't know it. So GPS, to be clear, is an American system of 24 satellites, but there's also GLONASS, the Russian system, there's a European system, there's a Chinese system. They all work roughly the same way. So you have a bunch of these satellites. All they are doing, essentially, are sending timestamps. And you have a device in your pocket or in your car that is very precisely calculated to that clock. And so because we know how long that signal should take to travel, if you have a clear line of sight to that satellite, we can figure out, if you take the timestamp and take your local time and subtract them, we can figure out how far away you are from that satellite. So if we assume the universe is 2 dimensions for the sake of argument, once you get that timestamp, we know that you are somewhere on the edge of that circle whose radius is that distance. So if we do that with a second satellite, we now know you're in one of 2 different places where those 2 circles intersect. We do it a third time, and we now know exactly where you are in this 2-dimensional world, minus whatever your precision happens to be. Of course, the real world is 3 dimensions at least, not 2 dimensions. So instead of having 3 different satellites to calculate 2 unknowns, we need 4 spheres to calculate 3 unknowns. But that's essentially how GPS works. Not that complicated. There's a bunch of other interesting fiddliness here. Theoretically, if you didn't care about altitude over the Earth, you could actually use the Earth as one of your 4 spheres. In practice, you don't, because there's a lot of complexity that I'm skipping over with clock drift and synchronization and other things that mean you always want at least 4 satellites anyway. But at this basic level, that is really how GPS works, which is cool. So if we jump back to this concept of urban canyons, this suddenly makes sense. So if you're in the middle of a city and there are all these giant skyscrapers, you are not getting this beautiful, clear line of sight to a satellite. That satellite signal is going to bounce off a skyscraper or 2, which means that time period is going to be longer. And when satellites on all different sides of you are reporting longer periods of time, that algorithm running on the phone in your pocket is going to be really confused and not know what to do with that data, hence really inaccurate data. So this maybe explains computational flaneur. Fort Mason is on the northern part of San Francisco. You can see there, it's right there on the waterfront. So you have this beautiful, clear line of sight to the sky. Also, it's in the marina, which it's not that hilly relative for San Francisco. There aren't really skyscrapers. This maybe explains why I wasn't getting 100 meters of accuracy. It doesn't necessarily explain why I was getting 2 or 3 instead of the 15 or 20 you might expect. I don't have a clear answer, but I have a bunch of hypotheses. So what we think of GPS and what I just described, that's not all your phone is doing. Your phone is now this very sophisticated device that does a whole bunch of other things. For example, the same way that it's using timestamps from satellites to figure out where you are and trilaterate, it's also doing that with cell tower data and known wireless networks. You may remember when the iPhone 3GS came out back in 2008, one of its big selling points was we have AGPS now, we can do this, which will get you faster data. We can also use caching servers. So when I said those GPS satellites are sending timestamps, that's a lie. They are sending timestamps, but they're also sending all sorts of other data, like up-to-date positioning of where exactly these satellites are. As you can imagine, that satellite communication link is pretty slow. So if you used a GPS device, like a handheld dedicated device like those, 15, 20 years ago, you might remember that it would take you 5 minutes, 10 minutes, 20 minutes to get a lock. One of the reasons for that is you had to go and download all the latest data. Your phone has an internet connection. You can download that from a web server, and it's way faster. Also, if you're in a space that is known to be inaccurate, people can set up ground stations that will send you offset data that your phone can automatically wrap in. So taking all that into account, it would make sense if there is a place in the world that is going to have as many of these bells and whistles as possible to get us better data, San Francisco is a good candidate. So it makes sense to me that taking all of these things into account, plus not having urban canyons, would make sense why Fort Mason is now this idyllic dreamscape in which to build great location experiences. But that's all GPS. What about things that aren't GPS? Some of you may have played around with like Bluetooth low energy beacons or Wi-Fi-based indoor positioning systems like Apple's indoor positioning. And so if you think about everything that I've talked about, it's this sort of high level, again, like if you have a location, that's great. Otherwise, you can use distance. You can use time as a proxy for distance, and satellite signals as a proxy for that time. That last step doesn't have to be the thing we care about. The way you locate yourself indoors with beacons, if you're trying to do sort of general position rather than just distance from a specific beacon, is exactly the same. You're using signal strength from a beacon to figure out how far away you are from that beacon. You can use a bunch of beacons to trilaterate where you are in a room. And it has all of the exact same problems that GPS do. Like if any of you have built out beacon-based experiences, you have probably been really frustrated by having a pretty good sense of where you are in the room, and then someone walks in between you and the beacon. And the same way that a giant skyscraper like bounces off that satellite signal, the signal strength of a beacon on the wall is attenuated through a human body in a way that means your phone no longer knows where you are. And that's super cool that, again, the same technology that powers literal satellites in space talking to your phone, it's fundamentally the same thing as here's a little piece of consumer microelectronics living on the wall in an art museum. But it also goes the other way as well. Sort of advances in this indoor location stuff can percolate back to GPS and other location. So if you look at modern Wi-Fi-based indoor positioning, which tend to be sort of the state of the art of if you want to do indoor location with a consumer smartphone rather than your own custom hardware, they are not just doing basic math like this. They're using sort of fingerprinting techniques and more probabilistic models where when you set up the space, like if you go ahead and talk to Apple and say, hey, we have this large space, we want indoor location, you're going to have to walk around with the device and do a calibration step and establish like what is the baseline, what does the space feel like from a signal standpoint. And then as a consumer using an app, you're going to be sort of probabilistically sampling where am I likely to be. And if you're asking, can we take that concept and all these models back to regular GPS, the answer is, of course you can. Uber is doing just that. They released a white paper recently about trying to solve this problem of what side of the street are you on when you're calling a car. And they're doing a bunch of other interesting things too, like they're building up 3D models of cities and trying to do raycasting and trying to predict the occlusion for urban canyons. But at a high level, that's the sort of thing they're doing, which is super cool. Like overall, I find this amazing that I set out to solve this problem of how does the GPS chip on your phone work. But it's not about the GPS chip. It's about this fundamental technology that is pretty basic math that spans back hundreds or thousands of years. And the same thing that powers those beacons on the wall and the satellites in space and sailors trying to get home hundreds of years ago are fundamentally the same. So great, this is all academically interesting. As a history nerd, if you can't tell, I love this. But does this actually matter? How does this translate to your day-to-day job designing or building software? I'm not 100% sure it does. I think I've found having this sort of basic understanding of how these things work definitely helps Like when things go wrong, it can give me an intuition of why they're going wrong, but it doesn't necessarily help me solve the problem. Because the thing about location services on phones is we are not operating at the level of satellites or timestamps. We are dealing with, in some cases, just getting sets of GPS coordinate pairs, in some cases, even higher level building blocks like visits or geofences. We're dealing with a different set of abstractions to solve different problems, which means maybe this lower level understanding isn't that useful. But I think it is still important to have this context and this appreciation of all the sort of underlying technology that we're building everything we do off of. So when I sat down to plan out this talk, I assumed the second half would be walking through the how then and looking at, well, if we have all these higher level building blocks, what are they? How do we think about how to deal with them? But I figured that that's interesting, but other people have done that. I highly recommend, there's a great WWDC video about testing your location-aware app without having to go there in person, which I think there's a separate discussion about. I think a lot of interesting location-based apps, you can't avoid doing a lot of in-person testing, but minimizing that is good. Runkeeper has a great talk about their history trying to optimize for battery life, because whether you're on iOS or Android, I think these two questions of testing and battery are the key questions. But I figured instead, it is early in the morning. Other people have covered these things pretty well before. I wanted to talk about the why, and what does it mean to actually be building these sorts of things? Why should we build them? Why is it important? Why is it so amazing that we no longer have to be thinking at the level of satellite signals or things like you may have had to worry about 10, 15 years ago as those of us building like cell phone tower-based pre-smartphone location experiences were? What does it matter? So if you think about when people talk about designing for mobile at this uselessly mile-high level, what's interesting about smartphones is people are out there in the real world trying to do something, and they have these tiny, awkward touchscreens, and they want to do whatever they're doing and get back to their lives. So designing an experience is much more about optimizing for what does the user want to do, help them do it, and get on with their lives. And that comes out of this idea that a phone is a tiny pocket computer with a small screen. And that's true, but a phone is also a tiny pocket computer with a small screen and a whole bunch of sensors. And I think the best UI is no UI. If you want to optimize for making users' lives easier, knowing what they want to do and helping them do it before they tell you is the best way to do that. And I think location services is one of the best ways we had to do that. At a basic level, anytime you've used or built out a locate me button in your app, you're saving the user having to type in their address or pick where they are on a map. But I think we can go farther than that. I think what is way more interesting about all this is what are the uses of location that enable ways for us to help people that wouldn't otherwise be possible. So I want to spend the next part of this talk talking a bit about what are some of these examples, what are the sorts of experiences that I've built or I've used that show here things that would not be possible without knowing where we are in the world. So this is an app called Cortado that I built 4 or 5 years ago. It's a caffeine tracking app. So I had this problem where I wanted to figure out what was the effect caffeine had on my body. How late in the day is too late? How much is too much? I wanted all this caffeine data sitting in Apple Health so I could correlate it with sleep data coming from an IoT device and try to crunch the numbers and figure out what was going on. But having to manually open your phone and type in every time you have a coffee is a major pain. Even more so, I know a lot of people who really struggle trying to do calorie counting with a calorie counting app because you have to remember to sit down and do it. This is even worse because you can't really do it at the end of the day if you want to remember exactly when did I have this coffee. But I'm someone, I usually drink coffee at a coffee shop. I'm a freelancer, I work out of coffee shops. So I built an app that knows when you're at a coffee shop, send me a push notification and say, hey, looks like you're at Hidden Coffee here in Barcelona around the corner. I know you usually have a flat white. Tap this button, we'll add it to Apple Health. You don't have to worry about anything. And for me, sure, tracking caffeine is not the most important thing in the world. I am not saving lives. But this was a meaningful case of something that gave me the tools to better myself that would not have been possible without this technology. And that's really cool and really powerful. As an aside, this app is available on the App Store. It's also open source on GitHub, although it's pretty old. It's all Objective-C and Reactive Cocoa, so approach with caution. But I think what's equally important about that is I looked into more complex ways of building it, but at the end of the day, I'm using Apple's visit detection API. I think Android has a similar API that is this monumentally high level. All I'm doing is saying, give me visits. Tell me when the user has been at a location for long enough that it registers as a quote-unquote visit. And Apple's APIs are not perfect. It has a lot of issues, especially for my use case of someone dropping into a coffee shop, grabbing a coffee, and leaving. But given that this, like, the actual interesting code here is a hello world level example, that's amazing that with so little work, I was able to build, again, this experience that pretty meaningfully changed my life. Sort of the higher level version of this, there's an app called Moves that many of you are familiar with that Facebook acquired and is sunsetting this month, RIP, that gives you this high level timeline of what have you been doing. This was my day on Wednesday when I arrived and went from the airport to the hotel and then went for a bike ride. And I have found it so incredibly useful to be able to go to my phone and offload, well, what did I actually do yesterday? When exactly did I arrive at this place? In a way that seems kind of silly, but you wouldn't recognize how useful that is until it exists. And this wouldn't exist if you had to open and manually log everything you did. But so these are all sort of tools and things that reduce friction. And that's cool. That's great. What I think is even more interesting is how can we use these to give you qualitatively different experiences and change the way you view the world? This is an app called Central Park, Listen to the Light, which is no longer available. This was an iPhone app in 2011. And it was an audio experience through Central Park, that as you walk through the entire park, every region of the park had a different soundscape. And as you walk from region to region, it seamlessly crossfades. So when you walk down the promenade, you hear the sort of interesting like drum pattern, and then you walk to the fountain and you hear something else. And it was fun to do once, good way to spend half an hour. But if you come back and do it day after day or week after week or month after month, you start to develop this sense of the geography of the park in context of the soundscape. And you build up this synesthetic feeling of a very different connection to the park that is interesting and unlike anything else I've ever felt. And again, not something you could have without this ambient awareness of where the user is. And that's sort of one of the things that inspired this poetry walk that I started out with, that this is not about the poetry. The poems are not interesting. They're generated by a neural network. They very much have the aesthetic of poems that were written by a computer that was just given a giant list of 20th century poetry. But that's not the point. The entire idea of the walk is how can we get you outside of yourself and give you the audio equivalent of doodling? So as you're walking through the park, I'm going to give you poems that are interesting enough to grab your attention, but not so interesting to hold your attention. So it serves like a meditation gong almost, that when you hear these things, you're going to be drawn into the world around you and appreciate the beauty of this park in a way that you otherwise wouldn't. And the entire reason that works is because there are these moments of serendipity when you hear a line of poetry that happens to particularly connect to the space around you in a way that feels like magic. And I could have played around with other procedural generation techniques to try to create that spark. But in the prototypes I did, nothing was even meaningfully near as effective as, well, I know you're by the cannons. Let's make something that is evocative of cannons, even if it's not literally talking about cannons. But it also doesn't all have to be about physical space and connecting you to physical spaces, although that's great. This is an app I worked on. My research group at the MIT Media Lab worked with the Dalai Lama Center for Ethics and Transformative Values. The Dalai Lama Center had this goal of how can we create more empathy in the world? And how can we give people this sense of the world outside themselves? And we'd love to use technology to do this. So 20 Day Stranger is an app that you would download. I think it's no longer available because academia. You would open it up and sign up, and you would connect with a stranger. And over the next 20 days, every time you opened this app on your phone, you would see a timeline of what your stranger's doing. They're going for a bike ride, and you'd see like a Google Street View hyperlapse of what they're doing. They're at a coffee shop, they're at a university, a construction site, they're at home sleeping, whatever. And they would feel like if they open their app, they would see the same for you, all being done through the same location services tech. The idea being that over the course of 20 days, you would get this ambient sense of what is this person's life like, what is their day-to-day, even as you don't know their name, maybe not even the city what they live in. You can maybe figure out country based off of street signs and language, but give you an appreciation for what is this life like outside of mine. And again, this would not have been possible without any of this. Like, we could have asked people to manually log in and journal what they were doing. A, they wouldn't do that. B, they would lie. Like, we found the design process for this was fascinating because there was this huge gap between the initial wireframes and user stories and thinking about, well, what is the ideal journey through someone's day going to look like? And that being completely different from, well, this is how people say they spend their days. How do they actually spend their days? And then how do we make this interesting to someone else trying to get a feel for them? And so that's really cool. What does all this mean? Hopefully this isn't just me rambling about cool things that I've built, because that's not that interesting. I think to me there's this really interesting through line of all of this stuff is still fundamentally built on these early technologies of location and distance from a location, and time as a proxy for distance, and satellite signals as a proxy for that. But now that we have the ability to use these much higher level APIs that I can build out Cortado in a very small amount of code, it can let us think about these higher level abstractions. And so we call the computers that sit on our desktops personal computers for historical reasons. But these things in our pockets are the most personal computers we've ever had, and not just because they live in our pockets and our purses, but because they have this huge ambient awareness of us, whether it is through location services or things like the depth sensor, like Tobias was talking about yesterday, or the altimeter, or the barometer, or all of these millions of sensors. And I think sort of we, as designers and developers, have an obligation to think through what we can be doing with these. And things like caffeine tracking and getting to know a park better isn't going to change the world. But I think there is an interesting thought experiment there. If you're going to build something like location services into your app, like yes, you can add a locate me button, and that is going to save users time. But how can we be building the equivalent of letting sailors find their way home at sea? What are the important experiences we could be building that would not otherwise be possible? And so hopefully, you should go out there and build amazing things. That's all I've got. Thanks.